Hello everyone, today I'm going to talk about research on networking. The contents of today's presentation are abstract, introduction, methodology, literature survey, outcomes, and conclusion. Abstract. A flying ad HOC network, also abbreviated as FANET, describes a self-organizing wireless network characterized by clusters of unmanned aerial vehicles, also referred to as drones, communicating with each other when in close proximity. FANETs are increasingly gaining use across smart ports, application, product delivery, construction, environmental and climate monitoring, and military surveillance. FANET's research is motivated by the prospect of the use of UAVs in motivation of the paper. This paper intends to analyze the most important FANET characteristics, mobility models, applications, and routing protocols in these regions. The purpose of this paper is an effort to provide a general description of the widely used different techniques of routing carried out by the most prominent routing protocols in FANETs that comprise topology-based, position-based, hierarchical, swan-based, and delay-tolerant networking protocols. Reinforcement and reinforcement learning fit within a newly anticipated class. Meanwhile, this research mainly focuses on a taxonomy for learning agents and learning models. Besides, this paper seeks to bring light into identification of applications of FANETs in different categories and research gaps and future possibilities in this area. Further, it compares the results qualitatively with that of the previous surveys. Future work in the routing protocol for FANET can be highly benefited from this paper as reference and roadmap. Introduction. Flying ad hoc networks are networks formed by the cooperation of unmanned aerial networks for specific objectives. Such networks play very important in environmental monitoring, searching and rescue services, and military operations where similar conventional infrastructure cannot exist. The UAVs can simultaneously act as communication nodes and routers. Thus, FANETs are dynamic networks with changing topologies. However, mobility of UAVs, energy constraints, and frequent topological changes pose a great challenge in routing. Routing protocols shall therefore be efficient such that they adapt to varying topologies and provide reliable data to destinations with an aim of minimizing power consumption. FANETs compared to other networks, MANETs and VANETs, entails a lot more challenges mainly because of the extremely high speed movement of UAVs in three-dimensional space. Again, it directly influences hardware performance, including good quality gearboxes. Coordination among several UAVs necessitates a proper communication protocol. SDN is regarded as the most promising with respect to full programmability in the network. Drives are powered through different sources, including batteries and fuel cells, though some are less preferred for the weight or lower energy density. Despite improvement of FANET routing protocols, connectivity problems, often topology changes, and node migration remain a serious challenge. Although most of the research did not place much emphasis on routing, managing the flow of data between UAVs effectively remains a critical matter which this research had addressed. Methodology. It can be solved by the following ways. The first way is flying architecture. A flying ad hoc network is a type of wireless network consisting of unmanned aerial vehicles and ground based stations that can communicate with one another in a self organizing manner without prior communication setup. This means that all entities involved in data transmission are responsible for establishing ad hoc communication between UAVs and GBSs. To significantly expand the network coverage, some high capability UAVs are selected as gateways between GBSs and the other UAVs. In addition, FANET applications are various in communications characteristics, network organizations, and features. This section is further divided into two subsections. The first one discusses the dominant organizations of FANET that are widely applied in the literature. The second one is UAV communication via ad hoc networks. It is predicted on a centralized administration with UAVs and other communicating on an ad hoc basis. The topology that this architecture can take can be in one of the forms of either a flat mesh network or a hierarchical mesh network, which are more compared to the more conventional form of star topology. Designed unmanned aerial vehicles from each group act as a gateway nodes, thus allowing for the number of groups to AUC7 keeps in touch with ground control unless there's necessity for communication in between units. Ground control is not involved in internal communications. A centralized unit where thousands of UAVs all have the various data, including flying characteristics, cannot compare to the reality of the setup. Particularly, data transfer via ground control, however, creates dependability issues in the semi-centralized setup. Literature survey. A survey on literature of routing protocols in FANETS discusses some of the strategies, categorizes them, and brings out the unresolved research challenges. FANET routing is complex due to the UAV's high mobility, frequent change in topologies, and limited power sources, and hence effective data communication is important. Multipath and QoS based protocols. These are based on quality of service with balancing by considering multiple routing paths. This identifies open research issues to be more efficient with energy, to mitigate frequent topology changes, improve security, and develop adaptive protocols which are real time. Key strategies are topology based protocols. The protocols depend completely on the network structure and consist of proactive, reactive, and hybrid approaches. Position based protocols. These are based on the geographical position of the UAVs to route data. This will be effective for highly dynamic networks. Clustering based protocols. In this type, UAVs are often formed into clusters in order to reduce the complexity of routing and improve scalability. The outcomes. The outcome of the survey on routing protocols of FANETS reflects significant advancements but faces some challenges still. That is classification of routing protocols. The survey categorizes the routing protocols successfully based on topology and based on position based, clustering based, and multipath or QoS based strategies. Each one of them promises certain benefits based on the requirement of the network in terms of its mobility, scale, and energy efficiency. Problems found. Topology changes frequently. Connectivity is always intermittent. Energy resources are limited and reliable communication in a dynamic environment poses key challenges. These factors make it complex to design routing protocols. Performance issues. A review reveals that a single routing protocol for FANETs has yet to emerge, which can be used universally. Protocols trade off between scalability, energy efficiency, real time adaptability, and quality of service. Conclusion. This research focuses deeply on FANET routing protocols, illuminating its salient features and real world implementations, highlighting the many benefits UAV based communication offers. Researchers working on possible applications have proposed and implemented a myriad of solutions. The article strives to, by describing the many types of UAVs used in FANETs, discuss their most important characteristics, applications, and routing protocols. It presents a detailed discussion about FANET research, a new taxonomy representing reinforcement learning and deep reinforcement learning algorithms is proposed. This paper discusses the taxonomy associated with the learning agents, whether single agent or multi-agent, as well as learning models that are model-based and free model. Thank you.